Good morning. Good morning if you are here in Europe. Today we're going to showcase a branching strategy selector. This is a work that was done for providing knowledge for the earnings service department, and today we're going to introduce it. However, in order to introduce it, it's better to have two sessions. And in the first one, we will just introduce some basic concepts about this. Okay. Okay. Let me introduce myself. I'm working for Ernie since quite more than 4 years. I have worked for Hewlett-Packard ever since, doing printer firmware development, and also software for external tools. And I'm still working there. And one of the things I like to do in computing is playing with version control systems. It's a topic I've always been very interested in. So basically, my experience with this version control since many years ago, I happened to use a very old system called SCCS by Sun Microsystems, and I also was very disgusted with Microsoft SourceSafe, which was a very bad and unsafe tool. Actually, I was very happy when I found out that Subversion was being created, unlike Linus Torvalds, because he says Subversion is a very disgusting tool. But you can watch a video about that if you like in Google, in YouTube. Okay. I also play with distributed version control systems, because I used to work on the road, literally on the road, installing systems on the road. So sometimes I had to work without internet connection. I tried Git in the very beginning when it was launched, but I didn't understand anything. It was too complex. I didn't understand anything. Maybe this happens to many of you. And when it became more popular, like 6 or 7 years ago, I tried it again. I like it. I understood a little bit or more. And I like it so much that I'm at work, I often use it over Subversion. So I have, in the same folders, I have the Subversion files and the Git files. And actually, I have not been able to use Git officially until this year. Okay, so but I have used it for many years now. Okay, the session for this the contents for these sessions are the target the contents are very for beginners, so it's not an advanced session. So the target is basically managers who will have to decide which branching strategy you have to choose. Also for product owners, which are the responsible for the product. Software architects who will handle the day-to-day or the project managers. And maybe it's not so much for DevOps engineers, because you are supposed, in case you are one, you are supposed to know more than me. So, or even, yeah. And of course, it's for developers. It's important that you have some knowledge about these topics. Okay. The objective for these two sessions, well, for the first one, which is introduction, basically we'll showcase the earnings services branching strategy selector, which is a tool which is very easy to use and will save you a lot of time. Okay, we will talk about this a little bit later. We will provide beginner level knowledge about branching strategies and Git workflows and branching patterns and many underlying related concepts. We will understand why they are useful, and this will help you decide which if you need one and the most suited for you at any time. And also, I will try to provide you with some best practice tips about branching and merging conflicts. Sorry. In session number 2, we will showcase the selector. We will not do that today. Okay. And the goal of this selector is basically, as you see here on the upper side. Here, this intends to be a wheel of fortune, because we know that many projects, the branching strategy they use is a bit random. It's a bit, okay, we'll use this one because, so with this selector, you will be able to choose your project in a very easy way. Okay. Okay, this is a spoiler for the next session. We will go very fast here. So what does the selector do? What it does is, of course, to select for you a branching strategy, and how it makes it, the inputs for this output is very easy to answer questions. So how many developers does your team have? Are you working in DevOps? Are you working in firmware? Do you have testing? Questions like that, and answering these questions, it will provide you a hopefully good branching strategy for you and your project. Okay, the contents for this session: we will see basic context about base branching strategies. We will see definitions for branching patterns, for branching strategies and Git workflows. We will see the benefits and the costs of using them. We will also see some branching concepts underlying. For example, one concept we will do a lot of talk about is the merge conflicts, about how to solve, avoiding, solving, and minimizing them. And finally, we will see a list of, especially of branching patterns, which is, we will define them a bit later, and also of branching strategies. We will also define them a bit later, okay? And in session number 2, we will see some other items very shortly about which items are involved in when selecting a branching strategy. We will see the components of a Git workflow, and we will see, and we'll do a demo about how the branching strategy selector works, okay? But not today. Today we go in session number 1. Session number 2 is next week. Okay, let's start. If you are ready, you can provide some emoticons in the chat if you like, or you can ask some questions. The expected length of this talk will be 1 hour, a bit more. Okay, so be patient, and also you can see the recording. No? Okay. Let's start. What is this thing about workflows, branching strategies, and patterns? Okay. Okay, branching strategy is the most important part of a Git workflow. A Git workflow, we will see, it's many other things, like it's represented here with these hexagons, and we will see that the contents of that next session. But the branching strategy is the most important part. Okay, here we can have also, if you like, some some abbreviations we're using in these slides. Maybe some of them have already been used. So branching strategy is BS, Git workflow. BCS means version control system. With a preceding D means distributed, means it doesn't need to be centralized or online. And PR, most of you know, it's a pull request. Okay, so let's focus. We have a branching strategy as part of a Git workflow. Okay, and more concepts. What is a branching pattern? A branching pattern is a way of sharing or integrating developer changes. It can also be defined as a way of managing the path to production or deployment. So it's for handling these kind of things. And a branching strategy can be defined as a set of branching patterns. It's more or less a definition, okay? At least one of them, or maybe 2 or 3, okay? We will see them in detail, okay? So we have on top the Git workflow, then we have branching strategy, and finally we have the branching patterns. This session will focus mainly on the branching patterns in the end, okay? Okay, and what is this, the branching strategies and patterns? It's basically a set of conventions, for humans, for developers. It's basically how you store and track your changes, how do you branch for creating a new task, a new development, and how do you merge? Merge means joining or integrating these changes, okay? It's like putting them together, okay? And also, how do you share, how do you publish, and how you deploy? This means, well, maybe if you don't know what the subject, maybe you think, okay, this is not so difficult, but you will see it's a human thing actually, and there are lots of things to know, okay? And you will see. So here we have this graphic here. You have a main line of development. You start working here, your task. Somebody else is working here in orange, and at some point, your work is merged into is joined because it had diverged before. Then your work is joined, and then the other people is joined. So that's how it works. And this symbol here means it's a set of conventions. How we do this thing, this checklist. Okay. I mean, what should we agree on these things? We have to agree on things like, are we going to work isolated? Are we going to share work often or very seldomly? What will be our publishing strategy? And also, what will be our versioning strategy? Are we going to have automatic versioning, or versioning will be done like with some release manager? These kind of things we have to agree. So you see these graphics, it's, oh, okay, I like to work isolated here, or no, I want to be sharing information continuously, or I want to be publishing very often or not so often, okay? And this is for the versioning, okay? Okay, so all this, maybe you have never been using, or you don't know you have been using, or for your next project and you don't know. Is this useful? What are the benefits of using branching strategies, workflows, and stuff? And what are the costs, of course? I mean, for example, do you need one? Is this just a thing we have to do because everybody does it, or is something we have to do? Okay. The answer is it will probably be useful. Okay. Your project development will be easier, and in the end, the company will save time and money. But you also have to be very careful, because if you choose one just for the sake of choosing one and having one, and the most trendy strategy, this one is very famous now. If you choose the wrong one, it will introduce obstacles and will interfere your development. Okay, so let's see. Okay, the benefits of these things. I mean, for example, the selector, as we said before, is something what will help you to choose one very easily. It will save the project manager days reading and asking colleagues, and will assure you don't pick a wrong one. At team level, the benefits are the following. You don't have inconsistent practices. All developers work or have to work the same way. You will have a clean and sound log history with hygiene. I mean, hope you don't have chaos like here on the right. I mean, this kind of chaotic histories that nobody can. Okay, you have the history, but nobody knows how to find this change. Okay, and you will also reduce time when publishing your work. Okay. Okay, I mentioned before, you will avoid also merge conflict. You see this cartoon here. I'm not sure if you can read it. I mean, you have maybe been in this situation. You're about to leave. You have to deliver something for tomorrow, so you're about to leave. And okay, I'm going to publish my changes. This is in Subversion, but can also be like that in Git. I'm going to commit, and you try it. Oh, I have merge conflicts. Oh my God! Then you maybe gonna spend 3 hours. You can spend a lot of time. So it's kind of a nightmare for developers when they have merge conflicts. Sometimes maybe not for you, but in general, it's very waste of time. Okay, and so with choosing a proper branching strategy, the one that suits more for you and your project, these conflicts should be at least minimized. And of course, at company level, choosing a proper strategy with the selector, but you can also do it with awareness. You will have a well-organized team. You will reduce time wastes and people stress, because when people have to do a lot of ceremony and stuff, they get stressed, they get angry, they get upset. Oh, I have to again this. Oh no, but it will reduce people stress and you will increase happiness, and you also maximize productivity. Back in February, we did a survey on internet, and we found that people think that using a proper one saves about 20 and 40% in developer time. We did an analysis. It was, of course, a subjective survey. It's not something we can quantify, but it's believed to save time and effort. Okay. What's the cost? This is not comes for free, but you have a price to pay, but depending on your requirements. Okay. Of course, you will probably have more ceremony and more bureaucracy for some operations. Maybe, not always. Maybe you will need an integration or release manager, somebody who takes care of handling all the merges, handling all the things like that. But maybe you have it already, so you may need to train and educate the developers, so they always do the things that they have to do, and they don't do their own way, and then nobody can get the work of these people. And the developers might need some time to adapt to this strategy. So you have to be so patient in the beginning, okay? I mean, this cartoon here, it's about this famous strip on internet, the XKCD. I mean, Git is complicated. You, at least to start, when I started, as I already said, when I started to use Git, I was absolutely, I didn't understand anything. So you need time to understand it and how to get used to the basic operations, like fetch, reset, merge, rebase, reflog. It's a very important operation for not losing your work. So here the joke is that, how does it work? I mean, well, just memorize commands, and if you don't understand, just make copies of your folders and start again and whatever. So you have to train your developers, and you have to train yourself, if possible, to use raw Git. Okay. Okay, let's go now with another concept. This is maybe, what time is it? Yeah, still, we are well on time. Okay, branching concepts. Okay, some of these concepts you know them, but maybe you don't know everything about them. I'm not going to discover anything for you, but I mean, what is a commit? I mean, everybody has idea what a commit is, okay? But depending on the tool you are using, depending on the VCS, it has different meanings, and it performs different operations, okay? For example, in Subversion, when you do a commit, you are storing your changes, you are sharing them with your colleagues and maybe on the internet, and you are also, of course, publishing. So you are publishing your work. Everybody will see your work in the centralized repository. In Git, instead, a commit is just, I'm going to store these works that I'm going to store here, and I know this works, so I save it, okay? So this makes differences between Subversion and Git, for example. In Git, you are encouraged to commit often. In Subversion, depending on which companies, you are not allowed to commit and to save your work because you may break the build or you may introduce a bug. So unless you're on a branch, you maybe you're not allowed to commit. I have worked in some environments where committing could take 2 or 3 days. I mean, I have some work to save, and I cannot do it because I don't have the code review approved. I have some discussion, and my code is burning here, and I cannot commit it. So if you don't have time to use a branch, it can be annoying not to be able to commit. Okay, I have taken for you this quote from a developer I found on internet. In Git, you have to commit often, very often, very often if possible. Perfect later, so later you take a look at what you have done, and then you publish when you are ready. But in the meantime, you have already saved your work, okay? Also, another concept that everybody knows, but well, let's see. What is a branch, okay? You see this here, this tree with some branches. It's very intuitive to talk about branches. I mean, for humans, we think a branch is as in a tree. It's a bifurcation of our work, okay? But in the version control systems, for example, in Subversion, a branch is a copy. It copies everything into another place. It's very cheap. It doesn't take resources of time. It's just a new copy of your files, of all the files. In Git, a branch is it's just a reference. It's just a label of the history. It's okay. I don't want to lose this. So, but you're not required to use branches for branching in Git. So it's a bit the concept that are maybe a little bit different. Okay. So, but in this presentation, we will stick to the human meaning, neither the Subversion, neither the Git. Well, when we talk about branch in this session, we will use the concept for branching, for diverging. Okay. And is it good to branch? Branching is very easy. It's very cheap, both in Git and Subversion. But the problem comes later. The problem comes when you want to integrate your work together. And this might not be so easy. Okay, it can be difficult. Okay, and actually that's what the branching patterns that we are going to see now are about. How to branch and how to join back. Okay, I mean, integrating can be a tough part. Okay, for example, in Subversion, merging is not really efficient because of design limitations. I refer you to the video by Linus Torvalds in Google many years ago. He really bashed Subversion. He says Subversion is, I'm not going to use any word, but Subversion, no. But because of design limitations. And when you branch, you're always increasing the complexity of your history, always. So when you are branching, is it good? Is it worth branching, or maybe it's better not to? Okay, so you see this image here. when people make branches at work and when they're analyzing, they see the branches like that linearly. But actually, when you branch and when the branches diverge in time, the separation and diverging is increasing over time. So the more time you spend without joining, the more difficult should be. Okay. Okay, branching, and the opposite is how to join the branches. I make here a very short reminder. I'm sure most of you know about this, but I know some people that are not so sure about it. So I will make a very short reminder. Okay, I'm sorry, my apologies if you already know about this, but this is an introductory level session. Okay. So okay, the two ways for joining branches are basically two: to merge and to rebase. Okay. If you see this graphic here, we have the master branch, which has diverged, and it's continuing to have commits on it, and then we have the feature branch here, okay, which has also some changes, and we want to join them. We have two ways of doing it. With the merge, we create here a new commit. Okay, now, assuming there are no merge conflicts, these two branches have been joined. Okay, very easy. Okay, yeah, okay. And what is a rebase? The rebase consists in taking the changes you have done here, okay, and putting them at the tip of the master branch. So we join them here, okay, and this is your feature. The same changes, or not exactly the same changes, but this is because but we have here, okay. So we continue on top of master. This reduces also a little bit the complexity of the branching, okay? And we also have a third, which is actually a subset, a cherry pick, which is used in Subversion and in Git. It's a special type of rebase that takes only one commit, okay? So a cherry pick would be just picking one of the commits here, okay? You can use the cherry command without pick to detect your changes, okay? In Subversion, we don't have these little balls, the little circles and changes. What we are also, when you work in Subversion, you are also doing merges and rebases. It's not explicit, but every time you do in Subversion an update and you take the code of your colleagues, what you're doing is you are doing a rebase because you're applying your changes over the other people's work. And for doing a merge, you have to do it with the commands especially dedicated for merging, but it's not the same as here as in Git. Okay, but in Subversion, you are also doing merges and rebases. Okay. Okay, let's go with a new topic. It's a topic that deserves a section on its own. Basically, we will introduce what the merge conflicts are, how to minimize them, and some concepts related to this. Okay. Maybe you can make a survey if you have the time. Can you tell us in the chat how often in your daily job on average, how often do you update or pull? How often do you commit or make a backup of your Subversion files? And how often do you share and publish or push? Okay, you can answer in the chat like, okay, I update once a week, or I update every day, or I update every hour, whatever. Okay, just give us your feedback, please. Okay, when do we have, regarding to this question, to this survey, when do we have to update, or when is it too frequent to update, or maybe not enough frequently? Because updating determines the probability of having merge conflicts. Okay, updating frequently helps reduce the complexity of the merge conflicts, not the merge conflict, but in itself. But if you integrate small changes every time, the complexity will be minor, okay? But if you update too often, or when you don't have to, you will get unexpected or potentially dangerous changes, not necessarily about building, and the isolation that maybe you were looking for your development is lost, okay? So in short, the probability of having merge conflicts in your daily life as a developer depends on basically on three items: the integration frequency, the code base size, and the location and distribution of changes in the code. Okay. let's see this. Let's see this. This concept. Okay, when it is what it is too often for integrating. Integrating means updating or also merging or rebasing. Okay, so how often do we have to integrate? I mean, it's difficult to define because or to quantify. Okay, that's why I made a survey. How often do you make it? Every week? Is it too much? Is it not too much? How many developers you have in your team? Depends on many factors. Okay. And also the delay before commit. Maybe you have to, as I say, 2 days before you can commit, okay? And the code base size, of course. The size of your changes versus the size of the code base, the larger is this ratio, the largest is the possibility of having a merge conflict. And also having few changes, this can compensate for a low integration frequency, okay? But we have to define what is low and what is small. It's very relative figures, okay? Another factor that helps, affects the probability of merge conflicts is the task distribution, the distribution of the location of tasks. Okay, if you work in some part of the code and your colleague works in another part of the code, even if you share very frequently, you will not have any conflicts. That's why. So it's important to try to be smart distributing the tasks. So every developers can work in one area and you will not have merge conflicts, okay? And also you can have you can do this by self-manage, or you can do this with a release manager who is distributing the tasks, okay? Types of merge conflicts. There are 3 types of merge conflicts, from the most trivial to the most severe, okay? You can have simple text conflict, is there's one, okay, when you have to integrate, oh, you have a merge conflict, okay, I open the merge tool and, it's very easy, okay, like this, okay, because, very easy, okay. Then this can get very complicated. If you spend a lot of time, and especially if somebody makes a refactor of some code you are working in, it can be an actual nightmare. And these tools are maybe sometimes useless and you have to apply them again by hand. And another type of conflict is the semantic conflict, which is perhaps the most dangerous, because it may not be detected because you have no merge conflicts actually by text, and the code it's still building, but you have a semantic conflict. Means, for example, if you rename a method and your colleague at the same time makes another call to the old method name, which is still existing, you will have a semantic conflict here. Okay. Now let me tell you some tips how to avoid banal merge conflicts. Okay, the way you work every day, you can reduce the conflicts. For example, enforcing the style before reviewing the changes. If everybody sticks to the same style guidelines, people later will not feel tempted to change when they are doing another change. Oh, what did this guy miss here? He didn't follow the conventions. Okay, I'm going to change here. But this change is not related to what are you doing? Why are you modifying this? It's not related to your change. Oh, but this guy, he didn't put like the tabs or whatever. Oh, don't do that, okay? Because then you will have more conflicts. Or do it on a specific commit, but only for fixing the style, okay? Or reducing code smells which are detected by SonarQube. But okay, I'm checking your answers. Okay, from Philippines. We have somebody from Philippines. Okay, hello, welcome. And some people say you are pulling every day, and some people once a day as a minimum. And okay, thank you. You can send more answers like that. Okay. Okay, so I have a trick for you. I have a trick to avoid avoid merge conflicts at all. It's only for you. Okay, you see this cartoon, this trick. You see the guy in the right. He calls his colleague, come here, please. And what happens? No. I wanted to make sure that I am the one to check in the files we are both editing. This way, the guy on the right side, he will not have the merge conflicts, and the guy on the left side, he will swallow the the conflicts. Okay, so this guy is a bit nasty. Okay, so you don't have to do this in theory. Okay, it's very bad teamwork. Okay. So in order to minimize your conflicts, what you can do is to also follow some teamwork and social themes. Like, for example, when you know there are two changes that will have conflicts, commit first the one which has the smallest and simplest change. Okay, so then it will be much easier to solve the conflicts. Okay, this trick that we had before, the zero conflict trees, which is it's of course a joke, a bad joke. Don't do it, please, because it can cause a lot of waste of time. Okay. Use peer review besides for code reviewing, do it for informing your colleagues that you are modifying something. Okay. This way, we will know that you are modifying something, and we can talk later if we have we can discuss who makes the commit first, or we will see each other. Okay. Also, you can use agile meetings in the daily meetings or weekly meetings. Everybody should know and should inform and get informed about possible upcoming conflicts. Okay, and of course you have to use the proper branching pattern. Okay. Okay. New topic. Okay, the branching patterns. This is perhaps the most important section of this talk. It's half past. Okay, well, we are pretty well on time. So okay, let's do them right now. Okay, the branching patterns. Okay, yes, you have this reminder, but maybe I'm talking a lot. I'm sorry. Remember that the branching strategy consists of at least one branching pattern, one or more usually. Okay, this is a reminder. Okay, let's see. Branching patterns related to integration, about sharing developers' work. This is another type of branching patterns, but let's see these ones. Okay. It's these ones: the main line, the feature, continuous integration, etc. Okay, we will see. The mainline integration. Okay. Sorry, what's happening? Okay. Yeah. The mainline integration. It's very simple. It's just you have just one line of integration, and you do a commit, and you don't branch actually. Okay. For many of you, they will say, oh, this branch is really not powerful, but I can assure you many people use it, especially when working alone. Many people are still using it, okay? Even though in practice, it does not exist because every developer will have, the sandbox of every developer is actually a branch because you have changes here and changes here. So you're actually having two branches or three, one per developer. But the point is that in the repository, you only have one line of development, okay? It's the main line. And all the branching patterns and strategies, they have this as a pattern because everybody has a main line, okay? Every strategy, okay? So this one is used everywhere. The feature branch, this I'm sure you know about it. It's the most used pattern. Here we have this in this image here. We have the blue commits is a feature branch, and the orange commit is also a feature branch, and in the end they are joined into the main line or master. Okay, so what you do is to do parallel and isolated development. You will not be taking changes from master. Okay, and it's not a hotfix branch, which is we will see much later. Okay, but you know all this. Everybody knows this branch, this pattern. Sorry. The develop branch. This is not used very, at least in my experience. This is not very widely used. Maybe for many of you it is, but I don't remember having used it very many times. Okay. If you see this image here, the orange, if you can read it, the orange line is the develop branch, and it's an integration branch for integrating before going into the main line, which is the green line. Okay, so it's kind of a buffer. It's for integrating and avoiding, and this way we keep a very healthy main line. So we run all the tests here, we experiments. They are joining the develop branch, and if there is some problem, it's not as bad as if there is a problem in the master branch. This adds complexity because, as you see here with the diagrams, there are lots of arrows coming up and down, okay? So it usually increases the complexity, but of course, it has also some benefits, okay? And this one is used by Gitflow. For one of the strategies, it's called, the most famous, it's called Gitflow. It's used by it and also by others, okay? This one, the continuous integration pattern, okay? Do not confuse this with the DevOps concept of continuous integration and continuous development. It has nothing to do with that. This is a branching pattern, not a DevOps stuff, okay? This consists, as you see here in the diagram, in integrating continuously. When I asked before, updating maybe at least every hour. Every hour when I have something, okay, I commit and I share, okay, every time, okay, and give me yours. So we are all the time exchanging. It's like, it's simulating that we are working on the same set of files and folders, okay? So we are integrating continuously. Advantage, it reduces drastically the probability of having any merge conflict at all, and especially the toughest ones, okay? As a variant, you may agree on being able to share code that breaks tests. Okay, hey, I'm going to share you this. It doesn't work because I have not finished, but maybe you can have the definition of the method and you can use it for compiling your code. But you can agree on that. Usually you will not do it, but you can do it. It can also be used as a team integration branch for integrating by subteams. And what it happens is that it provides a very coherent and low noise task delivery. Sorry. A team integration branch is a subset of the previous one. If in your project you have some developers for communication, some developers for user interface, some developers for the core of the application, every team can integrate in a separate branch, and only when their work together is finished, maybe then they can integrate with the other teams. Okay. A collaboration branch. This is also a subset of this previous one of the continuous integration. You do the same, but only in a hidden place. Nobody will see you, but you share continuously between two or three people who are working on a feature continuously. But the main, it says mainline here. It should not say mainline. It should say collaboration. Okay. You share your work continuously, but you don't affect the rest of the team or teams. Okay.
Sorry, Matt.
Yes.
Marin has a question.
Yeah. Continuous integration makes sense when developers are changing a huge chunk of code at once. No, it's just the opposite, I think. I mean, if we come back here, basically the idea is that you share code continuously and very small chunks of code. So the idea of that is, okay, I have to make a very large change, okay, but I deliver it by patches, only this one. This way, you ensure precisely that. With your example, you would probably cause if you do a refactor, for example, when you do a refactor, you will for sure cause conflicts. But if you do a refactor slowly and talking with your colleagues, you will avoid conflicts. So that's how you have to maybe you have to share your work even when it's not finished or even when it's not building. Okay, but you have to share so your colleagues can adapt to it. Okay, good question. Okay, yeah, thank you. No, thank you for asking. Yeah, yeah, we have seen that before. Experimental, future branch, environment branch. It's more or less the same. I mean, in case you are wondering, I have taken all this information from a web page. I will tell you later. The information about branching patterns, not the other, but this section I have taken from a web page. I have copied the image from there. And they make a section for each one of these, but it's mostly the same. It's the way of these experimental changes or future branches is to, for example, we're going to make an experiment, but this experiment will break things, okay? So we start working in a separate branch, and we will not integrate. We can maybe get the changes from the main line, but we will not do it. As you see, the changes are only in one direction. For the environment, for example, imagine you have one main line of code, but then you have a Windows version, you have a Linux version, and you have a Mac version for your product. You will have the main line, but then you will have three branches that will never join together, which have some changes for compiling with Windows specific, compiling with Linux, and compiling with Mac. And you have these three branches, and you get the changes from the main line, but of course you will not put the Windows changes for the Linux users. So you have separated. And by future, it's like an experiment, but for very future, and it's more or less the same. Okay. The point is that you don't create noise in the main line. Okay. In case you would have to, for example, if your experiment, you will have to integrate into the mainline, it will probably be complicated with conflicts. But you know it and you pay the price for that. Okay, no problem. This pattern, okay, I'm sure people who use GitHub, you already know it. GitHub or Bitbucket. It's sorry.
I'm aware. Is beta version is an experimental branch?
No, this comes later. These questions come. Beta versions are not experimental branches. It's something we will explain later. I will come to you later. Okay, primarily. Okay, thanks for the request. We will come later for that. Okay. So the squash and merge and rebase or rebase. As I said, if you work with GitHub or Bitbucket or other. All these layers about GitHub, about the raw Git. This is a very recent approach. This is recent for me. I didn't know about it like some months before. Basically, what you do is you have many changes, and before you integrate them, you squash them. You compress them into just one commit, and then you choose either to merge it or to rebase it into master. You can choose both options, okay? And this is useful because when you make some development, okay, you make some changes, and okay, I changed this. Oh, it doesn't work. I revert it, and then I tried that, and it doesn't work. And this didn't build, but I have to fix this build like 10 commits later. So your commit history, your branch history is very messy, okay? So what you will do is you compress in one commit. So your colleagues who don't care about your development history will not see it, and you will get that like this, okay? Here in this, I will explain the graphic, sorry. So imagine you have the master branch here, and this is your feature. You have 3 commits. Okay, what you do before integrating is to put them together into one, and then, whoops, you put them after master. And your branch, it can disappear, or you can delete it. Nobody cares about it anymore. Or if you care, don't delete it. But the master trunk doesn't care about it. If you go into GitHub and you create a new repository, or you can go into settings, you can configure how you merge. So you can do it with allowing merge commits, allow squash merging, or allow rebase merging. So you can combine this and get these possibilities. Okay. Okay, now we will come for the question that, you accumulate drinking water. Drink water. For me, yeah, okay, thank you. I don't have teeth a bit, sorry. Okay, what we have seen before is the integration branching patterns. Now we go with a different kind of patterns. It's the release branching patterns, okay? And we have this. It's a hotfix or a release branch or a maturity or a stable branch or the release train. We will go and see what happens. And I said again the reminder because with so many talking, maybe you don't remember. A branching strategy, which come late afterwards, it's at least one or more branching pattern, okay? So let's go with these release patterns, okay? Branching patterns. The hotfix. I mean, I think the word says it all. It's a hotfix. It's a fix which is hot in red here. You see, it's very urgent. The testers or the user, they discover a bug, and your manager comes, hey guys, we have to fix this. Leave all your work. We have to fix this. It's not working. It's destroying data in the customer. So you have to come with a hotfix now. And what you do is you don't depart from the develop branch. You come from production. You come from production code. Okay, you know this code was on version 2.2. You get this code, you fix the code, and then you put it back, without going into release branches, without going into develop. Okay. For some branching strategies, a hotfix is the same as a feature branch, but as you see, these concepts are very subjective. I mean, at the end, we're always rebasing, branching, and merging, but the meaning, it's developers, humans who give it. Okay, so these kind of things, it's conceptual, it's subjective. Okay. Okay. The release branch. Now come back to your question, primarily. Okay. A beta version is a release branch. Okay. In your company, you say, okay, we're going to release the beta version in November. So now we make a separate branch, and in this beta version, we will only put fixes for getting a stable release for the beta version for November. Okay, and the point is that some other people keep working on the main development, but these changes are not accepted on the beta version. Even if you told to your release manager, hey, I have this change. This feature is so cool. It's very nice. It's also simplifying the code, the refactor. The say, go away. No, we don't want your shit in the beta version code. You put it on the mainline, and it will come to mainline later. Okay, for another beta, for another version. But no, but it's very cool. What don't you understand about no? That's what your release manager will say. We don't want release branches are for stabilizing, not for new features. Okay. And also, when we make a change into the release branch, these changes have to go into the mainline. Okay, you see this here, F1 and F2. It's changes on the release branch that also have to go into the mainline, because otherwise they will be lost and will only stand on the release branch. Okay. A maturity branch. A maturity branch, by the name, if I tell you it's a stable version, for you it's very easy to understand what is this. Okay, so imagine you have to give a version for a tester or for a customer. You will not give them the mainline code, or the mainline version. You will give them a stable version. Okay, so from time to time you say, okay, this at this point of this release branch, the code is quite good. It does not have the lightest changes, but it's quite good. It's stable. So we will create a maturity branch. It's more like a tag. It's like a tag. It's more like okay, at this point the code was cool. Now you continue developing and creating bugs probably, but here this version is quite stable. Okay, it's also useful for a developer. Okay, I need to start a new feature, but maybe since it's a very small feature, it's an experimental one. I don't want your bugs in the mainline. I want a stable version. So you start developing from this stable version, from this maturity branch. Okay, or point. The release train. I mean, in some products or some projects, they make release when it's ready. When will you release your next version? When it's ready. But when? Next month? Next year? When it's ready. And for some time of customers, this is unacceptable. They want new changes continuously. So here you plan. What you do is to plan, okay, we will do a release in April. We will do a release in June. We will do a release in August, okay? And what you do is to break away from the mainline, you stabilize this version and you only put changes that in your agile meetings say, okay, this was a schedule for May. This was a schedule for June. So you will be only putting these changes on as promised to the customer or to your managers, you will continue working on the main line, but you will, in these branches, you will only do some specific changes. And then these changes, they have to go into the main, okay? So you can start the branch for June and the branch for September at the same time, and all these changes, they have to be put in the parent branches. So the changes are not lost in the branches. Not sure you understand. I mean, if you have any questions, but it's just to release frequently the code and only what is promised. Okay. And yes, sorry. There is a new, Marine is asking, in this sense, is there a new main every month? No, the main is below here. The main would go here, and these are these are the release range, the June release. So the main it continues independently. Some developers keep working on the main line, but this is only for releasing. Okay, we promised our customer that in June we would have this feature, so we only do this feature, and we don't give them some other changes which are maybe dangerous. Okay, we only will give them this, and the main line continues. So it's not a main, it's a release. Okay. Another pattern is what is called a release ready. Basically, it says, okay, we need to make sure that our main line or our trunk is always ready for production. So no matter what, we have to make sure that if we go to the main line and pick it, it works. Okay. Of course, this is intention. Maybe it's, you don't happen to do it, but it's the idea. This works better if below this main line you have a develop branch. So you can solve the noise in the develop branch, and only when develop branch is ready, you go into the main line. But I have worked, for example, in companies where they had this policy, the release ready mainline always healthy, but the builds were broken, the tests were broken, bugs were introduced all the time, and sometimes it's only an intention, and sometimes it happens. Okay, so it's kind of this. Okay, okay. I take now some water, as David says. Thank you. These are the patterns. I'm sorry, maybe a lot of information. Maybe you can review that. I will give you the link for this page where this is explained. Okay. Now we go with the branching strategies. These ones you have heard many times. These names very famous. Okay. Okay. Exactly. The branch was not so healthy. You know, it was always red. Okay. The branching strategies. Okay. Another time the reminder. I feel I have to do because so much I talk a lot, and I'm giving you a a complicated morning. Okay, a branching strategy, it's one or more branching patterns. Okay, in some cases, I will explain only the most popular branching strategies. The first ones are anti-strategies actually. I think many people have heard about Git flow. Also, we will talk about GitHub flow, trunk-based development, one flow, and GitLab flow. But these last two only very, very quickly. We will not go into detail. Okay. We start for what I call this is my own my own yelling, the anti-branching strategies. Okay. I think it's worth mentioning them because actually they are and they will always be very used, and everybody has used them at some time in their developer life. Okay, the first one, it sounds like a joke or not serious, but it's storing your version or releases in zip files. Okay, you have your code and you don't have a versioning system, or you don't know how to use it. So what you do? Okay. I will take the folder, I make a zip file, I put a label, this is version 1.0, and we go with this, okay? It's not very nice, but it's better than nothing. And it's better, actually, than some version control systems, like the one I mentioned in the beginning of Microsoft source safe, which could actually destroy your code. Okay. Another of this anti-branching strategy would be just having no branching strategy. Just commit your changes without branching and without any criteria or just that. It's very similar. It's very similar to the mainline integration, but it's even simpler. You just do what one commit. Okay, I go for lunch, commit, and like that. It's no strategy at all. Okay, but at least you save your changes. Another one is the anarchy. I mean, every developer on the team makes whatever they see fit, and this happens. I mean, and maybe most of you have done it sometime. At least me, I have done it. I do whatever I like or I can. Okay. Okay, this is the most famous branching strategy, the Git flow. It was created like maybe 10, 11 years ago by some guy, his name, Vincent Driesen. And it became very popular because it set a way to do branching, okay? And now you will see here with the names here and the operation, you will see many of the patterns that we have seen before, like the hotfixes. You see the hotfixes, as I said before. This graphic is very old, and I did it, and I didn't make it myself. It's from the author. You see the hotfixes. The hotfixes, they come from master, or what would be actually the production. Okay, here you make a hotfix and then you get it back. But then this hotfix, it has to go into the develop branch, which is the develop branch is the integration is the integration area. So the hotfix, it goes into production, but it also goes into develop. Okay. So you see this yellow line, which is develop, which is the main developing line. And from here we see that some feature branches, they get created. They come from the develop branch. And at some time, eventually, they get back into the develop branch. And at this point, for example, at this point here, the release manager decided to create a release branch. So they created a release branch. They did some fixes. These fixes, they go into develop, back into develop. Here, you see. And at some point, they also go into production. So you have to be careful not to forget to do this. Okay. And the good news about Git flow is that you have actually, how to say, you have wrappers, you have tools for using it. You can install them in Linux, for example, and I'm sure in Windows it's also possible. It's called Git. If you go into Linux, your repository, you look for Git flow and you find it. But actually, what you do is, okay, I'm going to create a release branch, and it creates a release branch, and then you get, okay, I'm going to integrate the release branch into develop, and you have some special commands for another application that makes this for you. And now I want to publish the release branch, and they publish the release branch. They do all this for you instead of you typing the commands. Okay, git branch create. No, they do it for you. It's a higher level. It's a higher level commands. Okay. The problem with this is it's very complicated. It's very in the end it gets very this graphic is very nice, very beautiful with all these colors and all these arrows. Looks very nice. But in the end, everybody says it's too complicated. Also, the log history becomes extremely messy and complicated because you don't see things like that. If you see at the log, it's very complicated and it's almost unmaintainable by humans. Okay, it creates mess. Okay. Okay, another branching strategy, the GitHub flow. Basically, you can only do feature branches. I mean, a hotfix is a feature branch here. Okay. And then so here, for example, you have this. Here you create a feature branch. Here you create a pull request. Your colleagues tell you, okay, fix this, fix this, fix this, fix this, okay. Or you're testing and you find some bugs, okay. And now, then you put back into the master. And that's it, nothing else. It's so simple that it's very limited, okay? Of course, there are also other branching strategies. There are in-betweens, like OneFlow and GitLab Flow, which claim to be a middle point between the large complexity of Git Flow and the too simple GitHub Flow. They can also be very flexible, more flexible than GitHub Flow, and also more scalable. I mean, you can use a subset of the concepts of the patterns of these ones. And there are many others, okay? And I will provide you the links if you like later, okay? Okay, the conclusions for this session, okay? We are getting to the end, so I'm gonna let you soon. Many people ask this question, okay, please, a manager, you know, say, hey, I want the best one for my team. Give me the best one. Which one is the best? The answer is simple. There is no best one, not for all these scenarios. It depends on many things. It depends on how many people you are, if you are doing DevOps, if you are doing firmware. It depends on many things, okay? It depends on the testing policy you have. The problem here is that humans, you know, some people, they think that this branching strategy is the best. I've used it always and it rocks, it's so cool, it's so powerful, it's so simple. Maybe you are used to it, maybe you are biased, but maybe it not fits all the projects. Some of them can be work for many projects, but not all of them. Also, you have people who say, okay, oh, I heard this branching strategy like Git Flow, it's very complicated, it's very bad. Yeah, maybe it's bad, but for some corporations, they need to use releases, they need to use develop integration branches. So some companies are forced to use something like Git Flow. So it depends. And here I make you a reminder that in next session next week, we will showcase the Ernie branching strategy selector, which can help you if you have no idea about branching. It will help you asking some questions. It will help you quite a lot. Okay. Coming back to this, what is the best one? As I told you, I took this information about branching patterns. I mean, this thing about branching patterns, we have heard about it, but in this article, it's very well explained, and so I quoted it from there. So in this article, this Martin Fowler, is a very influential developer. He's the chief scientist at a company called ThoughtWorks, which makes very high-tech projects. He's a very renowned book author. He made books about UML a long time ago in the beginning. He made a very famous book about refactoring. He made also things about Agile. He was one of the founders. It's a very influential person, okay? Back in the 90s, he advocated for something which is called XP. That's called extreme programming. So this guy, he has a very strong opinion about, he prefers continuous integration. He says not always, but most of the time, okay? Why? Because it minimizes merge conflict. As you see, this kind of very good developer, what he's most scared of is about merge conflicts. Okay, so, and with this policy, with this pattern, this disappears. If I want to humbly disagree with him, because I have almost never used this kind of pattern, but it depends, of course. But I have never used it, and I don't think it's the best one for everybody. But in my experience, for most of the time, it's not useful because it takes a lot of noise. But it depends. It depends on how you work and, of course, how your colleagues work. Okay. So, okay, conclusions finally. Okay. Just a reminder of the tips I gave you for a smooth branching. Okay. Most important is human and social things. You have to play as a team. Be always consistent. Don't allow anarchy in your team. You have to define, agree, and use a branching strategy. It's very convenient. You can start with something simple using the selector. You can choose it with awareness, like studying why it's better for us, why not. Otherwise, you can use the selector, as I said. When you are working with it, with your branching strategy, you have to analyze if it's working, and if not, find out why. And be flexible. You can always change. You can always change it. Don't be scared about it. Just discuss it and change it if it is required. Okay? And finally, the tip for minimizing merge conflicts is to talk to each other. Just talk. Use your social skills. Okay? Don't be shy. Don't be quiet. Inform your colleagues about your changes and ask them about what they are doing in case they are quiet people. Ask them what they are doing so you can prevent or expect conflicts like that. Okay? Do you have any questions? You can ask them on the chat because we are not here in person, and if you have questions, just tell them in the chat. Everything is clear. Was it too long? It took 1 hour, basically 1 hour. I thought it would take longer. I have talked a lot, I'm sure about it. No questions? Then, okay, yeah. Yeah. Where can I access the branching strategy selector? We will disclose that on the session on next week, okay? I want to tell you something about the selector. A selector is always a work in progress. I mean, all the time there are these new trends, new things. Like for example, as I told you, this one, this one, the squash and merge, I discovered maybe last month, so I didn't know about it. Okay, so as I said, the selector will be disclosed next session next week. Okay, thank you very much. Yeah, next session is next week. Yeah, in the develop branch in Git flow, is the develop branch in Git flow No. So primarily is asking. Let's go to Git flow here. Is the develop branch in Git flow the maintenance for bugs? No. As I said, the bugs, you don't take them from develop, you take them from the production code. Okay? And when your fix is ready, you put it into develop. But you come from production or from master. Okay? And but you don't. It's important. I said it here, I think. Hotfix branch departs from production code, not from mainline and not from develop. Okay. Next question. No questions. Nice to see. Very informational. Thank you. Okay. So thank you very much, and hopefully we will see next week. Okay. Yeah.
Thursday?
I think, no, next Thursday. Jueves. Thursday. Dijous. Okay. Thank you to you. Thank you. Bye-bye. Bye-bye. See you next week on Thursday.